New to Imatest 24.2, the Concentric Rings Field of View module offers an innovative solution for accurately measuring field of view based on the ISO 8600 standard. The Concentric Rings Field of View module is a fixed, batch-capable software module that automatically detects and analyzes images of concentric ring targets. The ISO 8600-3 2019 standard was originally created to measure the field of view for endoscopes. This design has been augmented for automatic analysis in Imatest and can be customized for a wide variety of camera lens systems that require longer or shorter testing distances. For a known working distance, Z, each ring radius R on the target corresponds with a field of view, which can be calculated using a simple trigonomic relationship. To account for asymmetric cases, Imatest calculates the individual field angle for 8 radial directions extending from the center of the target. For a known working distance, Z, each ring radius R on the target corresponds with a particular field angle, which can be similarly calculated. The full field of view for a particular axis is then the sum of the two opposite field angles that comprise one axis. In this example, the vertical field of view for a camera lens system is calculated using the north and south radial directions. Photograph the chart, taking care to center the registration mark with the center of the image frame. The chart should be evenly illuminated to avoid glare, which can be problematic for accurate detection of the rings. The chart should be in focus and should fill the entire image frame if possible. Load images into Imatest by dragging and dropping them into the Source Images tab in the main window. Select the analysis by clicking Next. Select the Concentric Rings FOV module, which can be found in the list of distortion targets. Open Settings by clicking the gear icon on the Concentric Rings FOV analysis card. Imatest supports two main types of concentric ring targets: constant angle and constant distance. A default preset for the IMA FOV 1X chart is also available in the Target Design dropdown. This chart is inspired by the ISO 8600 standard and is an example of a constant angle target with rings spaced 2 degrees apart beginning at 30 degrees for an intended working distance of 50 millimeters. Specify your working distance in the test setup parameters. Imatest calculates the FOV for your camera lens system as a function of this working distance and the radii of the rings. The batch save settings dictate the format and file save location for your analysis results. When analyzing a batch of images, separate results files will be created for each image. The plot save settings allow you to choose the output save format for your plots and whether you want to save and/or display the available plots at the end of analysis. The save location settings allow you to customize how your results files are named and the file location where they are saved. Once all of the settings have been chosen, click the Save button in the bottom right before returning to the Analyze tab. After returning to the main window, ensure you have selected your test images. Then click the Analyze button to begin the analysis. You can keep track of the analysis progress in the console if you have the info logging level selected. For the following examples, Test Image 1 contains slight blur and minimal distortion. Test Image 2 contains barrel distortion and minor vignetting. Plot 1 displays the ring radius in pixels plotted against the estimated field angle in degrees for each of the 8 radial directions. When analyzing constant angle images with little to no distortion, expect to see a slight upward curve in each of the lines, as shown in the plot for Test Image 1. Plot 2 contains the analysis image marked with the detected ring locations along each of the 8 radial lines, and a summary of the estimated field angles and directional fields of view. Plot 3 estimates the relative distortion by plotting the true ring radius in millimeters, calculated from input chart parameters in the Chart Properties Settings section against the estimated ring radius in millimeters that is derived from the test image. This plot makes it easy to quickly identify the presence of distortion in your test images in real-world units. Plot 4 is the same as Plot 3, but it estimates the relative distortion in pixels. This plot makes it easy to quickly identify the presence of distortion in image space units. As a disclaimer, we note that both versions of the relative distortion plots make the assumption that there is no distortion in the image from the chart's center to the first ring. This assumption allows us to estimate the millimeters per pixel conversion for the given test image, which is used to calculate the chart-derived ring radii. Explore the capabilities of our concentric ring field of view module and see the difference it makes in your visual quality analysis. For more information, please visit imatest.com/8600 or email sales@imatest.com.